This video will show you how to determine rate of reaction using data and constructing tangent lines on a graph. So what I'm doing here is I'm setting up my axes and labeling them. So on my x-axis, I'm going to have time. And if you notice on the data, time goes from 0 to 200 seconds. So I set aside 20 squares, where each square will correspond to 10 seconds. And so now I'm just labeling the increments on my x-axis. And notice that I don't have to put a label for every tick mark on my x-axis. I only put in, I believe, 50, 100, 150, and 200 seconds. So once I'm done with my x-axis, I'm going to do the same thing for my y-axis. And if you look at the data, the y-axis corresponds to the concentration of hydrogen peroxide in moles per liter. So because I use 20 squares for my x-axis, I'm going to use 20 squares for my y-axis as well. Again, looking at the data, the highest value we have for concentration is 0.2. So for 20 squares, each square is going to correspond to 0.01 moles per liter. And again, I'm not labeling every tick mark on my y-axis, only the most important ones. So once you have your axes set up, let's plot our data points using the data. Once you've carefully plotted your data points, it's time to connect most, if not all, of those data points using a line or curve of best fit. The important thing here is to use a smooth line or a smooth curve. Make sure that you're not just connecting the dots. Make sure that it's not bumpy. So it helps to use a pencil to do this. And then I'm going to go over it in pen so it's easier to see. Now we're going to use our graph to determine the rate of reaction at 40 seconds. So find that point on your curve and construct a tangent line at that point, which means a line that approximates the slope of the curve at that point and touches the curve only at that point. So once you have your tangent line, identify 2 points in order to be able to determine slope. When looking for 2 points to use in order to determine the slope of the line, I find that it's easier to look for 2 points that are at an intersection of 2 lines. So there's less estimation involved when determining the x and y coordinates of those points. Also notice that I'm writing down the coordinates of the points that I'm going to use so that when I write down my calculation for rate of reaction or for slope, my calculation goes much quicker and there's less room for error. Now, remember that the units for rate of reaction depend on the units for the slope of our line. So in this case, the units for our y-axis are moles per liter and the units of our x-axis are in seconds. So the units for our rate of reaction will be in moles per liter per second. I'm going to repeat the same procedure to determine the rate at 150 seconds. Now just by looking at the curve, you can tell already that the slope is decreasing over time. So one important thing to do when you're calculating or when you're determining rates using tangent lines is that you check your work and see that it makes sense. So as I'm going through this, I should be expecting a rate that is lower than the rate at 40 seconds because at this point there are less reactants in the system and less reactions occurring. So hopefully this video was helpful in showing you how to determine rate of reaction using tangent lines on a curve of best fit. I also have a video that shows how to use your calculator in order to graph data and determine rates of reaction using regression on the TI-84 and the function that allows you to determine slope at particular points on a curve or on a line. So that would be a good video to watch next.